Ah, you guys are already online. Good morning, everyone. Welcome back to my YouTube channel. Are you guys hearing me? Are you hearing me? Say good morning, Bro G. Good morning. Good morning, Messi. Good morning, Gold. Good morning, Peace. Good morning, Solomon. Good morning, Bino Achibo. You can literally hear the bird sound and the hen crowing. You guys are doing well. You guys like your grade more than my health. Because I say life by this time. Welcome back to my YouTube channel. So as I said, today we are just going to do our practical life. No, not too much stress of editing and all those stuff. So we are going to do our practical life, and I want you to pay close attention. Everything we are going to be doing here, we're putting it directly to your manual. No time to come and be doing it later. You don't have time again. Let's close the chapter of manual. Now, while we're waiting for others, please share the link to your status, to your platform, to your departmental faculty platform, so that we'll start. As I told you guys earlier, you need to be live because I might decide to put this video on private and you might not see it again. So let's do everything together today. You can hear me? Say yes, I can hear you, Bro G. Good morning everyone. Welcome back to my YouTube channel. Good morning. So let's post it on our status and our departmental platform that we are starting now. Yeah, let's do that immediately. So that we'll dive in. Okay, since you can hear me and we are already here, we are about 45 here. While the rest are joining us, I want to make some correction in experiment 5.7. So this is my graph here. I believe you guys can see it. This was the first graph, and I plotted a straight line graph from the origin. You can see that this is the first one here. Let me say extension 2 was at 22 and the other one was at 8. Please open your manual and check this work. This one was at 200 and this one was at 540. So let's say this is 540 before 550, the bold line here. And I think when plotting this, I made a little mistake. So this is 540 here, and this is 200, which is correct. This is 22. Let's check. This is 22 and this is 8. So this is 22 and this is 8. So 540 minus 200 will give us 3 I believe that's the one I'm solving. Yeah, 340 divided by 14. So this will give us 24.228. And I told you that the range of the slope is 20 to 25. No need to be asking if you are correct, if you are within this range, because I've plotted 3 different graphs. The first one I got 22.10, the second one I got 25 dots, and the third one here I got 24.20. So please, anything you are having within this range, you are correct. Now this slope is directly your force constant. I told you guys that if I'm doing this guy here, K is equal to Fx. So from this equation, Y is equal to mx. Now what's the m? M is equal to what? Y all over x. So this is automatically, the slope here is automatically the force constant, K. So please take note. So I believe I've verified this. Plot a graph of, no? Okay, I'm not with the question here. Let me check if I'll see the question here. Okay, I believe I've verified this. Yeah, it obeys Hooke's law. And I've verified this. Plot a graph of load against extension. Obtain the spring value from the graph, which is your slope. The spring value here is your spring value. Spring constant, K, is equal to your slope. So please, if you have any question, you ask on the YouTube channel, yeah, in the comment section, I'll reply you. So before I continue, don't forget to subscribe and share this link to your colleagues, to your departmental platform. Now, after doing that, the next one, I think I made a little mistake again. Sorry for the mistake. I think it's due to stress. Now, I derived this guy, which I believe this is in your manual. Yeah, this should be in your manual. Now, the second one was plot a graph of t squared against m. Now, if you check here, my t squared is 0.45. So that's what I got here. That's t squared 2. Then t squared 1 is 0.15. Is that what I wrote here? Yeah, 45 and 15. Now, t squared m2 is, please, this is where the mistake came from. You can see this is looking like 800. It's supposed to be 5, so I put 800 by mistake. Please, the main thing is that you understood what I was doing in that video of Hooke's law. So that's the main thing. I've said this and I've preached it over and over again. Do not copy my slope. Do not copy your friend's slope. Do your slope and make sure it hits the range. So from here it's supposed to be 500, not 800. So people might have 450 here, some people might have 550, 520. You must not have 500. As far as you understand what you are doing, you'll be on the safe side. So here, 500 minus, let me call this 170 or 80 down here. So let me check if I had that. Yeah, 170. If I punch my calculator, I'll have this. So this therefore will be, this will change. So this will be 330. So this minus this 0.13 divided by 330. 0.13 divided by 330. I'll have something like 0.00039. Yeah, 0.00039. So this will be 3.9 times 10 raised to the power minus 4 s squared all over g. Now, another person might decide to have 2.0 to 4.0 times 10 raised to the power minus 4. That's the range. You are still on the safe side when doing this. Don't cancel your work because you didn't have what Brush J Academic Space have in his YouTube video in experiment 5.7. Now I think I've clarified that. So that's the mistake. Is there any other mistake? The other one is someone asked me, all this thing should be tomorrow live session, because I know you people have many questions from the beginning of experiment 3, 4, 5.7 and 9. We are doing live session tomorrow. Put it in your schedule and it will be by 7 to 8. Now, another person asked me, sir, please, my intercept here cross to the t-square axis. No, your intercept is supposed to cross through the m axis. Normally, it's supposed to pass through the origin. But now, they told us in the manual that the intercept on the m axis gives the effective mass of the spring. Give the effective mass on the spring. So therefore, it's going to pass through the intercept. Now, if you're having from 10 to 50, that's a good range for your effective mass, which is the intercept on the m axis. So your range, if you're having 10 to 50 grams, this is still correct as your effective mass. Please take note. You must not copy everything I'm doing. So if you understand, type continue so that I know that I will continue. Let's enter experiment 9. Okay, good says she don't understand the effective mass. The effective mass is simply the intercept that cross through the m axis. So that's your effective mass. That's what the textbook says. The intercept on the m axis gives the effective mass of the spring. Do you understand now? Yeah, on phone, we are going to explain experiment 9. I just said let me clarify some things in experiment 5.7 so that when others come to watch the video later, don't understand that, okay, bro, you have tackled one or two things here. Now let's go to experiment 9. Now experiment 9, practical application of simple pendulum. Now before I start this, I'm going to derive this this equation. I'm going to interpret this equation. I believe you all can hear me. Now, number one, tabulate your results. Now, all of you should bring out your results because we don't have time to fill this. You already know your results, the table of this. So I'm just going to fill the height and the t-square for us, so that we can use it to plot all the graph we are having today. So from what you guys did in the experiment, or the value was given as 11.22, 10.89, 10.56, 9.61, 9.30, 9.00, 8.41. Yeah, you're asked to add another column. Now, my height was given as 10.00, 20.00, 30.00, 40.00, 50.00, 60.00, 70.00. Plot a graph of t square, s square against m in centimeter. Calculate the slope of the graph and the error in it. Now this error, we have a little issue here. Now we don't know if this error, so we should find the standard error and standard error, which is W all over N, or the error in slope, which is 4W all over N arrow. Now I'm going to skip this in this video. You'll do this on your own, but I'll direct you on how to do it. But now, since they are not giving us the standard error or the error in slope, I don't know how we are going to be doing this or plotting this. I don't know if you understand. Now, from the slope, find the acceleration of free fall g together with the error of measurement. That means if you are presenting your g, this is what they say. The range of g is 9 to, let me say, 11.0. Now, if you are getting 10.5, represent it with the error. It will be plus or minus the error you are having here. The error you are having here, let me say someone has 0.02. So this is how you are presenting it. So that's why they say with the error of the measurement. So this is how you are presenting your G. Please take note of this one. Now determine the intercept of the graph on the t-axis. That means you're asked to plot a graph of this height against t square. So therefore, we are determining the intercept on t-axis. So, sorry, you are asked to plot a graph of t against h. So this is t square and this is h. So this is where your intercept will be looking from. Now, find the height of the ceiling h, capital letter H, from the intercept of the graph on the t-axis. This is very simple. This five precaution that need to be taken in this experiment, this you are going to answer this in the comment section. I avoided error due to parallax. I avoided personal error by putting the whole point in 0 points, by putting everything in 2 decimal places, or if I'm starting with 1 decimal places, everything is in 1 decimal places. I ensure that my stopwatch was functioning well. I think that was one of the parameters used. Stopwatch. Yeah. I ensured that my pendulum ball was moving well without air resistance or without air circulation. So that's for the precaution. You can name as many as you have, but they say 5. So deal with just 5. So now let's dive in while we do this practical. Now, let me use marker so that I'll be able to see well. Are you guys hearing me? Okay, let's continue since you guys are hearing me. Now, very important, we have to find this equation, derive it to y is equal to mx plus c. Now, looking at this equation, they say plot page 1, experiment 9. Looking at this equation, they say we should plot a graph of what? Let's check. T squared against small h. That means t squared will be on the y-axis against small h will be on the x-axis. Hope you understand that part. Now, what's the next thing you are supposed to do here is write the equation. T is equal to 2 pi square root of h minus small h all over g, equation 1. T squared, we square both sides. So if I'm squaring both sides, I'll have t squared is equal to 4 pi square, bracket open, h minus small h all over g, bracket close. So therefore, I open this bracket, t squared is equal to 4 square h minus 4 square small h all over g all over g. Now therefore, t square is equal to minus 4 pi square small h plus, I'm moving this guy here and I'm moving this guy here, plus 4 pi square big H all over g all over g. So therefore, my y, which is here, is equal to m dot x. This is my x here. That's my plus c. Everything here is c. And everything here. So looking at this minus here, that means we'll be having minus. So therefore, everything here is my m. So I believe you understand that part. So therefore, the nature of this graph will be looking like this, because it has a negative slope. So this will be my t square and this will be my m. So the nature of the graph will be looking like this. Now it's supposed to pass through both it's supposed to pass through the both axes, but from what we are going to plot, it's going to be like this. Yeah, it's going to be like this, which is still correct because of the table given to us. So this is 0.0, this is 0.0. Now, why is our slope having this? It's because we are having a negative slope. Is that clear? Do you understand? So you write on, bro G. So what I'm doing here, just copy and paste in your manual direct. So what's the next step we are going to be doing? After knowing this, that our t square is equal to minus 4 pi square all over g plus 4 pi square h all over g. I believe nobody is seeing my wrapper that I'm tying because of you guys. So that's page 1. Now the next thing, after knowing this, we are going to be, with this equation, we can solve our g and we can solve our h here. Remember, they say we should, the main m, I told you anytime you are giving experiment, read the m to measure the height of the ceiling using simple pendulum. So this is the main m of this experiment. So to find the height of the ceiling, which is capital letter H. Okay, nobody's seeing my wrapper. Thank God. So what's the next thing to solve here? Let's dive in while we plot the graph. From our manual, let's use the manual graph so that we'll not hear story that, sir, you use the green graph, that's why your own is like this. Sir, you use the red graph, that's why your own is like this. So our graph is here. Now I'm going to use another color of marker. Plot the graph of t square in second square against a graph, please, in capital letter, of t square second square against h in centimeter. So that's number 1. Now what's the next thing? Let's label our graph. So this will be t square in second square against h in centimeter. Let's take note of that. Where's my ruler? Is what I'm plotting. Be plotting. First, let me use this so that you see where. If you like, go and use marker. I say, if you like, go and do what? Use marker. Your village people will be stronger than you. Now, for visibility's sake, I'm going to be using marker so that you guys can see it well. So I believe you can see it now. Who is this one asking me if the class will be done by 7? You are learning something very important. You are checking time. No problem. So let's continue. The major reason why I'm doing this video is to make sure that you understand what you are doing with me, because it seems when you guys do it on your own, you have a lot of confusion. I don't understand where you guys are getting the confusion from. So this is 0.0, Now, 117 is the most simplest exam to have an A. In fact, it's the most simplest assessment or practical to have 40 over 40 if the mark is 40 over 40, or 50 over 50, or 60 over 60, or 70 over 70. Please, pencil. I don't know if you can use pen, but since I've been plotting graph for over many years now, I've been using pencil. So you can ask if you're allowed to use pen. But let's continue. This one is just for the visibility sake so that everybody will understand and see what I'm doing. Now, the t-axis, I'll be using scale. Please use my scale so that I will avoid so many questions. I'll be writing my scale. And this scale, I'll be using, let 1 centimeter represents 1 second square on the t-axis. So page 2 in experiment 9. Scale. Let 1 centimeter represent 1 second square on t square s square axis. Let 1 centimeter represent 10 centimeter on h centimeter axis. I believe you can see it very well. Now write that exactly the way I wrote it. I don't want to hear any story. What's the next thing? We have gotten our scale, we have labeled our graph, we have titled our graph. The next thing is to plot our graph. Now, this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's stop at 12. Why this will be 10, 20, 30, 40, 50, 60, 70, 80. You can see that it's joined because it's marker. It's marker. It's bolder. It's marker. We are using marker. When it was at 10, the height is 10 here. This is 11.2. 11 at 10 is 11.2. Don't pay it like my own. So visibility sake. When it's in 20, the height is 20. This is 10.89. So 20, let me assume this is 10.89. In between 8 and 11, in between 10.8 and 11.0, because each of this line is 11.2, 11.4, 11.6, 11.8, then 12. So you need to know how to read your box as you are scaling it. Now the next one is 30 and 10.56. 30, 10.56. So in between 10.4 and 10.6. The next one is 40, 9.6. 40, 9.6. 9.6 is here. You can see the tiny line here. 50, 9.3. 50, 9.3. So 9.3 will be between 9.2 and 9.4. 60 is 9.0. 60, 9.0. 70, 8.4. 70, 8.4 is here watching us. Ta-da! Experiment 9 is almost done. Use pencil. Use pencil. Before you say it's Roger that says you should use pen. Roger Academic Space didn't say you should use pen. Use pencil. Jesus. We spin. Come, hope nobody's seeing my wrapper. Writing your title with pen is okay. Writing your title with pen is okay. Your daughter has finished. Look for data because this class is very interesting. Now, I believe everybody have done this. I'm waiting for you guys to do this before I continue. So that everybody will be saying, my slope is this. My intercept is this. My G, my capital letter H, which is the height of the ceiling, is this. So are you done with this? If you are done, say I'm done. If you are not done, say wait for me. Okay, I'm waiting for you, Esther. I'm waiting for you, Rose. I'm waiting for you. I'm waiting for you guys. Please be fast so that we'll finish on time. Now the main thing is to get this graph. Okay, done. Let's move on. Dara said let's move on. Anybody that said let's move on, I'll continue. So I believe now this is not hard. Is this hard? This is not hard. Where are you guys getting all the confusion from? Done. Okay. Another person is done. So now let's pick our best fit. Should I use marker or pen? Let me use pen. So in case you want to find the error yourself. This entered. This entered. You can cycle it. You're allowed to cycle. This entered. This entered. This entered. Now one here is not entering. You can observe that this one here is not entering and this one here is not entering. So you can decide to find, you can see that this is not entering. The only issue you people used to have is you don't know how to draw a best fit line. Use a transparent ruler. I'm still using a metal ruler and I'm getting a good best fit line. So one here is not entering, one here is not entering. You can see. Before you say, Roger, how do you do your own that one didn't enter? How do you do this? Where do you do this? Roger, this, Roger, that. You can see that one is not entering, one is not entering. From here, we can get our W. I did a video on how to get your vertical scatter. If you have not watched it, please go and watch it. And make sure you share it in your platform. Share it to your colleague, share it to your family and friends, share it to your village people. Let me hear that you have error in this graph I'm plotting. Me and all of you wear the same trouser. in this piece. Now you can see I'm plotting my vertical scatter. I'm not going to solve anything concerning vertical scatter. Watch the video and solve it to find your error. But this is the only thing I'm going to advise you. Find the standard error instead. Just find the standard error, which is W all over N. Don't go and stress yourself and be finding error in slope. Find standard error, get into this and plot, find the error and move on. Then you can decide to find error in slope, which is 4W all over N arrow. This will be a very long process. So just find, they didn't indicate, you can see, they didn't indicate the error for you to look for. See, they say, calculate the slope and of the graph and the error in it. So I advise all of you, let's use this. Find your error and make sure your error is from 0.0 to 0.9. Anything more than 9 in your error. I don't know what to say. I'll not say anything. I reserve my comment. So let's continue. This question of pen and pencil, I think you need to ask your colleague or your class rep to call the coordinator. It will really help you guys. I can't answer that here, so that will not lead some people astray. So what's the next thing? Can I continue? Say right on, sir. Okay, let's write on. So therefore, from here, look at this closely. I'm just going to pick any gradient line of my choice. Ruler steady now. Let me use marker so that you see this. So I draw a line. This line is looking big, oh Jesus. Let me reduce it. So let's trace this one down. Let's trace this one down. Let's trace this one to the vertical axis, and let's trace this one to the horizontal, the vertical axis. So therefore, remember, here is my T2, and here is my, sorry, here is my H2, here is my H1, here is my T2 square, and here is my T1 square. So please don't write all this on your graph. You have your manual to write this. What's the next thing we are going to do here? Let's find our slope so that we can put it in our number 3. Number 3. Now when you are writing your slope, you write your slope in this manner. This is how you write your slope. I'm going to plot my slope here, and I'll tell you the manner to write your slope. So question number 3. Question 3. Calculate the slope. So let's calculate the slope. Don't forget to do the error and put it in the comment section, please. So the slope is change in slope, which is M, is equal to change in T square all over change in H. T square 2 minus T square 1 all over H2 minus H1. So therefore, this will be equal to, what's my T square 2? 11. So this is 11.0 minus, you can have 10 points. I think this is 10.8. Let me leave it 11. Remember, I don't copy my slope. This is 10.8 if I'm looking well. 10.80, but let me leave it as 11.6.0 divided by H2 is what? This is 20 here. 20 minus, so if this is 80, this is 90, this is 100, this is 110. So here is 110. You can see. You need to draw your numbers on the horizontal axis so that you can get your reading for the slope. So therefore, we have this will be equal to 11 minus 6 will give us 5, right? And 20 minus 110 will give us minus 90. 5 divided by this will give us 0.05. Meaning that 0.05. My scale is big, oh. My slope is very big. Now, from Broglie Academic Space Personal Experiment, you know, physics is made easier here. This is what I discovered, that if I'm having a slope of this range, 0.039 to 0.0043. Let me bring this down. 0.039 to 0.043. If I'm having a range here, my G will be equal to 9.0 to, my G will fall in this range, 11.0, which you are correct. But now my slope here is I'm having 0.05. 0.05. Please make sure your slope is falling in this range. Now the first slope I did here, when plotting this guy, you can see I plotted it before. Before you say Broglie, Broglie fan. Are you guys seeing it? Please, you are seeing it, say yes, I can see it. I'm waiting for you because I think my network just... Okay, thank God. I thought my network had messed up again. Okay, now if you see this, you see what I did before, and I got my slope was... Where's my slope? My slope was minus 0.0747. So having that, I told you the range. Having that, I got as my G, I got, in fact, 0.077 is high. It's still high. So make sure your slope fits in here, because I'm having 822.4, because if you divide it by 100, you have 8.2. So, but I use 0.03. When putting it here, I have 9.6. So that's the manipulation you need to know, the background work you need to know when solving physics. So your slope should be 0.039 to 0.043. Who got 0.475? Good, nice work. You try. That's a nice one. So I've been preaching, don't copy my slope. Just understand what you are doing. So always understand what you are doing. 0.0 minus 0.004. I got minus 0.004. I got minus 0. Are you having 004? Where are you getting the double zero from? 0.06. Yeah, remember it's minus, so it's minus. Please note it's minus. You're supposed to have a negative slope from this interpretation. Please, physics is not hard to understand. From this interpretation, see, you're supposed to have a negative slope. Negative slope. 0.046. Good, you're on the right track. Mistake. Mistake from where? From me or from you? Please, I believe, from what I've taught, nobody should make mistake in this class. Nobody, I repeat, nobody should make mistake. Even though I'm making mistake, don't try and make mistake. In fact, I'm not making mistake. I just know that you need to reduce this. Please reduce this. Let me say, make it here. Now, your G is dependent on your slope. If your slope is too big, the gradient line is too big or too small, it will affect your G. So you need to be careful when picking this G. Now, with understanding this, let's move. So I'll still keep my minus 0.055. 0.055. Please, I'll still use my own, but I'm not going to have the range of the G. But I'll keep it for teaching sake so that you understand. Mine is 0.06. Your own is too high. It's too high. I got 0.05. It's still too high. Please don't get 0.05. That's why I say some of you have copied my slope. Don't copy my slope. You can still reduce yours to be like this from here. So just try this, guys, so that, remember, I'll tell you the range of your slope. This will guide you in plotting this so that you get your G. I'll show you how I manipulated this. So let's continue. Now, after having my slope and having my intercept, what's my intercept here? Please, let's take note. My intercept here is 12. Please, I'm having 12 here as my intercept on the t square axis is equal to 12. Please take note of this one. Let's be fast so that we'll round up. Now, the next thing here is to do is to find your acceleration, find the slope. Sorry, from this slope, find acceleration of free fall, that's G, together with error of measurement. So this is the error of measurement you took here. So let me assume that since my slope is minus, so I'll say my M here is equal to minus 0.055 plus or minus, this is assumption, 0.02. This is how you write your slope for them. Please, this is assumption. Those that will come and be asking me, sir, how do you have 0.02? I know what I'll do to you guys. This is assumption. So you go and find your error in this graph. I've given you vertical scatter. I've given you a video to watch and understand vertical scatter and error. So let's continue. Now the next thing is, from your slope, find the acceleration. That's, you should find G with the error. This error you have here, you should write it with G. I told you here. So therefore, is any page left? This is page 1, page 2, page 3. Experiment 9. So therefore, I'll have something like, from this equation, where's my equation? My minus M from the equation, minus M is equal to minus 4 pi square all over G. You can see where we are getting it from here. From here, you carry this and equate to this. So minus will cancel minus. My M now, which is the slope, is equal to 4 pi square all over G. So therefore, what's my G? G times M is equal to 4 pi square. M, G alone is equal to 4 pi square all over M. So therefore, G is equal to 4 times pi square all over 0. Remember, I've cancelled the minus sign, so this will not be 0.0. What do I have as my slope? 5. So from there, if I do 4 times pi square, or have 39.48 divided by 0.055 divided by 0.055. I'm having 717.79. 717.79. Now, you can see that I'm out of the range because of what I got in my slope. Now, let's do some manipulation. Let's come back to this equation. This is the most important equation here. My G is equal to 4 pi square divided by, remember I told you guys the range. So let me look at the range again. Let me assume that my G was my slope was in 0.039. Now let's check what we have here. 4 pi square is equal to, divided by 0.039. I'm having 1012.27, approximated that. If I divide this by 100, I'll have 10.2. Sorry, 10.12. You see? You see the manipulation I did there, right? In fact, it's not manipulation. You see the work I did there. Now, if I erase this, now anything you're having from here to 0.043 as your slope, from here to here, you see that you'll be on the right track of having G. Say, I understand, sir. Are you guys here? Good. I love that. Jesus, where are my pages? So I've given you scope of your slope. Your slope should be 0.039 to 0.043. Anything you're having here, the way your G will give you like my own G, like you're in Mars or Jupiter, or you are in Australia. For those that are not understanding, go and watch Introduction to Physics 111, 117, Part 1 and Part 2. Also watch the vertical scatter explanation in error in slope or error in G. Then later you come and watch this video. You see as everything is just entering your brain. You'll be like, oh. So don't forget to also subscribe, like, and share to your colleagues this live video so that they'll watch it when they are done with their classes. Because sometimes you might not see it again on YouTube. So please watch it on time. Now, what's the next one here? Determine the intercept. I determined my intercept since now. This is my intercept. My intercept here is equal to 12. Please, it must not be my own. From 11, 12, you are still correct. That's my intercept, 12. So I've gotten this answer here. 12, intercept, second square. My slope, make sure I've already gotten this. No need to write here. Now they say, find the height of the ceiling H from the intercept of the graph on the t square axis. That's our last thing today, and we call it a day. Page 1, page 2, page 3, page 4. Hey, I don't have page 4. If my wrapper fall down. Page 4. Experiment 9. Your intercept is 11.8. Write it in the comment section. That's very correct. Your intercept is 12.2. Beautiful. Please, more intercept. More intercept. My G is 8.9. If you approximate it to this thing, you have 9.0. That's still sweet. That's very sweet. Intercept is 12.2. Correct. Yeah, that's a nice idea. Go for your practical, then you watch it later. That's beautiful. So what's the last thing we are going to do before calling today? We answer number 6. Number 7, put it on the comment section. Let me check if you are correct. Anyone that is correct, I'll reply. Anyone that is not correct, I'll reply. But make sure it's 5. Don't go and do something that you'll be going the wrong way. Number 7, from the equation we derive. So if you don't know how to derive equation or interpret equation, that's where your problem starts. From equation, we have C, which is the intercept, is equal to 4 pi square all over G. 4 pi square H, sorry, all over G. 11.4, that's correct. The main thing is to understand, and I'm happy that you guys got the message from this video. Thank you so much. So therefore, I'll cross multiply. I'm making H subject formula. So this will be CG is equal to 4 pi square H. I'll divide both sides by 4 pi square. 4 pi square. This will cancel this. My H alone is equal to CG all over 4 pi square. Now from this you can get this. My own intercept was 12. My G was 7. You convert this to this thing so that you have the right answer for H. My G was 7 points. I've divided it by 100. So it's not more, it's no longer 7 points. It's no longer 717, it's 7.17. But you know that this is a wrong G. Divided by 4 pi square. I believe if I make subject formula correct, I believe this change of subject formula is correct. This. Okay, it's correct. So therefore, my H will be equal to 12 times 7.17 is equal to divided by 4 pi square. So my answer will be given as 2 points. So this is 2.18 centimeter. So this is the end of the video. Now let's round it up. A, tabulate your results. You did that. Number 1, tabulate your results. You did that. Plot a graph of T against H. We did that. Calculate the slope and the error in it. We did that. From the slope, find the acceleration of free fall G together with the error in measurement. We did that. Determine the intercept of the graph on the t-axis. We did that. Find the height of the ceiling, capital letter H, from the intercept of the graph. You can see we are using the intercept of the graph, t square. We did that. List 5 precautions that need to be taken in this experiment. You do that. You want to do that. Put it in the comment section. So for more physics practical and physics tip, please don't forget to subscribe, give it a thumbs up, like this video, and share to your colleagues. We'll see you in our next video. Let's call it a section. Clap hand for Brother J. Clap hand for yourself and clap hand for Brother J. So if you are owing me my mod, bring it to class. See you in our next video. Thank you for joining the live stream, and thank you for understanding. Have a beautiful and a wonderful day.